Welcome to the Vinci Science Center in Allentown, Pennsylvania for our Women in Science and Engineering event. At Da Vinci, we are passionate about supporting women in STEM fields and inspiring young people to follow in their footsteps. STEM jobs are growing in our region and across the country, and women are not represented equally. Here at Da Vinci, it's our job to encourage and support today's young girls so they can become tomorrow's STEM workforce. One way we do that is by introducing female STEM role models like today's presenter. Camille Schrier, who was crowned Miss America in December 2019, is a STEM advocate with dual degrees in biochemistry and systems biology, and is currently pursuing her Doctor of Pharmacy at Virginia Commonwealth University. Camille broke from tradition to perform the catalytic decomposition of hydrogen peroxide as her onstage talent during the Miss America competition. Her unique talent performance and focus on women in STEM has sparked a positive reaction of inclusivity. Today, Camille will perform this demonstration live for you. Please welcome Miss America 2020 Camille Schrier to do her catalytic decomposition of hydrogen peroxide.
Good morning, everyone. How are you? I know that there's lots of people watching at home, and we have a few people here with us live. I'm Camille Schrier. I'm Miss America 2020, and I'm a huge science nerd. And that is part of why I am here today. So make sure that you guys interact live on the video. I know you guys can actually see and maybe even ask some questions live. So definitely interact and stop me if you have a question. We're going to have a whole lot of fun. And so today we're going to do the demonstration that actually helped me win Miss America. But I want to tell you a little bit about me before we do that, because why in the world did I decide to do a chemistry demonstration at Miss America? That doesn't really always seem to totally fit together, and that's what's really cool about this. So since the time that the entire time I can remember, since I was a little girl, I loved science, and you might too. I loved nature. And when I was little, I liked to go outside and pick up snakes and frogs and bugs and go fishing, and I didn't want to put on a dress, and I wanted to be in the mud, which is totally cool. But maybe you wouldn't think that that little girl would want to grow up to be Miss America, but she totally can. And so all of those things that I loved in nature actually were biology, so the study of living things. And maybe I was in the kitchen cooking and baking, and that is a lot of chemistry. And so we study chemicals and the way that they interact. And so as I got older, I realized that what I really liked was science. And so we talk about STEM, so science, technology, engineering, and math. And I really fell in love with that S piece in STEM. But of course, you need all of the other pieces to have a successful career in science. But the cool thing is you can figure out which piece of that you like and pursue that. And I always tell people, it's not important that you are super amazing at every single little piece of STEM, but finding what you're good at and where your skills and passions are is really important too. And so that's what that exposure when I was young really helped me to do. So I loved science, I loved being outside, I loved animals, I still do, and I ended up really liking chemistry. And so when I went to college, I figured I'm going to study biochemistry because I couldn't pick. But honestly, I had started in a lot of different careers and I wasn't totally sure what I wanted to major in. So I found biochemistry. I also have a really cool degree in something called systems biology, which sounds kind of confusing, but it's biology using systems like computer technology. So maybe we use computers to help solve problems. And in this case, we were using computers to solve biological problems. But I didn't tell you anything about why I have a crown on my head, did I? So I graduated from Virginia Tech in 2018, and I decided to go to pharmacy school. And we maybe have interacted with pharmacists before if you've gone to maybe a Rite Aid or a CVS and gotten a prescription filled from a doctor. And that person behind the counter is called a pharmacist, and they have special training, and they are the medication experts. And that's what I wanted to do. So I went to pharmacy school, and in the middle of doing maybe 10 courses, I'm in the middle, I'm stressed out, I'm taking tests, and I see an advertisement come up on my Facebook page during lunch. I was allowed to be on Facebook during lunch. And it was for a local competition for Miss Virginia. And Miss Virginia is a scholarship organization, and it goes to Miss America if you win, and you can win a lot of scholarship money. And so I said, this would be kind of a cool opportunity. Why not try this? And the funny thing was, there's a talent competition. And usually during the talent competition at Miss America, it's not like America's Got Talent. That's usually what people assume that it's like. But we really only see about 5 talents, typically. We see women that sing, women that can dance, women that can play an instrument. Maybe you can twirl a baton, or you are a ventriloquist, so you play with puppets. I can't do any of those things. Nobody wants to hear me sing. Nobody wants to watch me dance. I can't do those things. And so I kind of figured I don't have a talent. I can't compete. But that's really silly when we put ourselves in that box to say, oh, I don't have a talent. There's this barrier in the way that makes me not able to do something. But one of the really important things about science is innovation. So being creative and solving problems that we see in front of us. And I think that being a woman of science helped me be able to be creative. And so I said, hey, you know what I could do? I'm talented at science. That's what I've loved my whole life. Maybe the girl next to me has been in ballet class since she was 4. Well, I've been picking up bugs and snakes since I was 4 and learning about science, and that was always what my interest was. So I wanted to do a chemistry demonstration particularly, or some kind of a science demonstration. I landed on this one. This is called elephant's toothpaste, and I picked this for a couple reasons. So one of the things when you're on stage, I had 90 seconds, so I had to do this really fast. I also needed to make sure that I was able to engage and entertain every single person in that room, because it's really performance. If I was going to entertain the same way that the girl who sang really, really well before me did, I need to make sure that this is exciting. And it was a really great way to visually show some basic chemistry concepts in a really quick amount of time. So I chose elephant's toothpaste, and now I get to travel around the country as Miss America with my chemicals, which I think is a problem that the Miss America organization maybe has not seen before, is how to travel Miss America around with chemicals, but we figured it out. And I get to bring STEM to thousands and thousands of kids across the country, which is just so much fun for me, being the science nerd that I am. So I want to talk to you a little bit about what this demonstration really is. And I'm going to give you the longer version, the non-90-second version of how I do this, because it's really important to understand some really basic concepts, and it's pretty fun. But before we do science, it's really, really important that we are protected. And so I have my lab coat on, and that's part of my personal protective equipment. And that's something that we've actually heard in the news recently. With COVID, we're talking about PPE. We're talking about having masks on. That is a part of personal protective equipment. But when we do science, we also want to make sure that we are protecting ourselves. So I have my lab coat on. So I'm going to button up my lab coat. Got to make sure I do that. I also have long hair. And so if I didn't already have it pulled back into a ponytail, I would pull it back. I also have closed-toed shoes on, which you can't necessarily see. And I am going to make sure that I put some gloves on. Let me get these on. And then my last step is to protect my eyes. I'm going to put my goggles on. And the cool thing is, just because you have to wear personal protective equipment doesn't mean you can't have pink safety glasses. You know what I mean? So I always wear my pink safety glasses. I also have a pair that are bedazzled. So we like to make safety super fun and cool. I also have a blinged out lab coat that I wear sometimes. I wear that at Miss America. There's no reason you can't have fun when you're doing science, right? So this demonstration is pretty simple. You can actually do it at home with home chemicals, but the one that I'm doing today has more industrial lab strength chemicals, which make it extra exciting. But there is a way that you can do this at home. So I'm going to tell you guys a little bit about what is in each of these flasks. And it's important that I say flask. We actually have different names for different glassware in science. And so this shape of a glass is called an Erlenmeyer flask. It's big at the bottom and it's tapered at the top. This little glass that's kind of more cylindrical, this is a beaker, versus you wouldn't call something like this a beaker. Love my glassware. So in my Erlenmeyer flask, I have 3 ingredients. I have hydrogen peroxide, I have food coloring, and I have dish soap. And hydrogen peroxide is probably something that you've all used before. We use it maybe when we have a cut or a scrape, and we pour it on our skin to clean it out. It forms lots of bubbles. And that actual action of seeing those bubbles when you have a cut or a scrape is almost the same thing that's going to happen in this demonstration, but it happens a little bit differently. So in your body, you have something called catalase that actually breaks that hydrogen peroxide down, and it forms the bubbles that you see. So when you pour it in a cut, you get the bubbles that form, and that actually helps to bring the dirt and bacteria out. And so we're going to kind of mimic that with chemicals today. And so we have 35% hydrogen peroxide in my vessel. And I have to tell you, if you've used hydrogen peroxide at home and you get a brown bottle from the pharmacy, that's about 3% hydrogen peroxide. So this is around 12 times stronger than that. So this is really, really concentrated. It's really strong and it can burn your skin, which is why it's so important that I have gloves and glasses on right now. So I have my concentrated hydrogen peroxide. And the other thing that I want to mention is that hydrogen peroxide I said comes in a brown bottle. You've seen it maybe in your CVS, your pharmacy. It's in that brown bottle because this hydrogen peroxide breaks down over time and with light. Lots of things break hydrogen peroxide down. The light, which is why we have that dark, dark bottle. It's like blackout curtains in your house. So it protects the light from coming in and it keeps it from breaking down so that when you buy that hydrogen peroxide, you actually know that it's the same concentration that what they're telling you it is. You want to make sure that it stays strong. My hydrogen peroxide, I said, also broke down when I poured it on my cut because I have an enzyme in my body called catalase that breaks it down. And what that catalase is a catalyst. And if you think about the word catalase, it kind of tells you a little bit that it's a catalyst. But what is a catalyst? And I like to describe a catalyst like riding your bike up a hill. Stay with me here. So you have your bike and you're going up a mountain, right? It's really hard if you've ever tried to ride your bike up a hill and you get really tired and it takes you really long. You get up the top and you're like, okay, this took me really long. But what if you had a motor on your bike? If you put a motor on your bike, you would get up the hill faster. You wouldn't have to do as much work. You'd get up, it would be so much easier. And that is pretty much what a catalyst is. The catalyst is like the motor on your bike. But the interesting thing is it would be more like the physical motor, not the gasoline, because a catalyst is something that actually is not consumed during the reaction. It remains there. So instead of like you would pour gasoline in your motor and it would energize it up the hill, but at the top it would be gone, it's really the motor that is the catalyst. And so the catalase in our body, and we also have chemical catalysts that do the same thing, and they help make the reaction go faster. So I mentioned that hydrogen peroxide is in that brown bottle because it's breaking down with light. It also breaks down with time. And I have to tell you, it's breaking down right now in my flasks. Do you see it breaking down? Do you see the bubbles? Nobody sees any bubbles because it's going so slow. Spoiler alert. And that is really boring. And I'm impatient. So I like to make sure that my reactions go super fast because honestly, that's a lot more fun. And when I was at Miss America, I only had 90 seconds to do my demonstration. So I had to make sure that it happened really, really quickly. And that is what the catalyst is able to do for me. It actually breaks down the hydrogen peroxide really, really quickly. But if you've ever seen elephant's toothpaste before, you know that it's very foamy, right? So we talked about hydrogen peroxide breaking down, but why is it foamy? That's important to think about too. And hydrogen peroxide is actually chemically pretty similar to water. We know that water is H2O and hydrogen peroxide is H2O2. So we have an extra oxygen on there. So when we break down that hydrogen peroxide, we're actually going to clip off one of those extra oxygens off the side of it. And that oxygen comes out as gas from our liquid. And usually when gas comes out of a liquid, we form bubbles. But if we can trap all those gases by using something like dish soap, which I told you I put in here, we're going to turn all that gas into bubbles. And so we're going to see those bubbles form, and that will tell us that the hydrogen peroxide is breaking down. But also when we form or break chemical bonds, we see something that is like an energy release. So we're actually going to see heat forming. That's called an exothermic reaction, which means heat is released, and that is really an energy release when chemical bonds are formed or broken. So when I do this, I want you to look for steam. You might see some steam, and these vessels, the glass actually gets really, really hot when I do this. And so it's important that we make sure that we stay safe when we do this as well. But I think now, time to start our elephant's toothpaste. Also, spoiler alert, you cannot brush your elephant's teeth with this. Do not do that. That would not be safe for your elephant. Okay, now we're going to run down this one more quick time. In my Erlenmeyer flask, we have hydrogen peroxide, food coloring, and dish soap. The hydrogen peroxide is going to break down and release oxygen gas that gets trapped in my dish soap and forms foam, which will shoot out, and that shows us that the reaction has progressed. We're also going to see heat because it is an exothermic reaction. I'm going to pour in something called potassium iodide, which is a chemical catalyst which will start the breakdown and speed it up really, really fast, but it will remain in there. It's not going to get consumed. It's just going to work like that motor on my bike. Does that sound good? Should we count it down? Let's count it down from 5. 5, 4, 3, 2, 1. See, this was supposed to be purple, but it's not the coolest purple I've ever seen. But what's really important here is that you can see the steam, and you can even see it in the camera. This is a lot of steam. And look at how little. I only put about 20 milliliters of that catalyst in here, and I had about 200 milliliters of hydrogen peroxide in there. And look at the quantity of foam that actually was created and the quantity of heat. Actually, when I did this once, I had an infrared gun that actually took the temperature. It was almost 200 degrees within that instantaneous pouring. Also, to get into my glassware, when you think about if you have something really, really hot and then you put it on a cold surface, it expands and contracts really fast. So sometimes the glass can crack. So I use very special scientific glass that will not crack under really quick temperature changes. But look at how this continues to go. This foam will continue to come out until one of the chemicals kind of eats up the other. So whether or not all the hydrogen peroxide is all done breaking down, or maybe I put too much catalyst in, or put too little catalyst in and there ends up not being enough. So one of the things, that's called a limiting reagent, basically. So one thing runs out and it stops, or the other thing runs out and it stops. But it'll keep going until one of them runs out. And this is really cool. And I brought this to Miss America and made a huge mess on stage. But what's really important about this, even outside of the fact that it's super cool and foamy and I love science, is that sometimes you end up being the only person doing something. And that's also an important piece of this, because people thought I was crazy to do a science demonstration at Miss America because only one person had ever done it before. And they were just like, I don't really know why you're going to do this. It's not really a talent. And I'm like, why is it not a talent? If you've done something your entire life and it's your passion and love and that's what you've dedicated your time and effort in learning, then I think that that is just as good as any other talent. And I think that it's important to show, especially any young person who's watching this, or any young person in your life, that it's okay to be different. It's okay to take a risk and just be yourself, because I am the super science nerd. I told you I've been like that since I was a little girl. And so this was true to who I was. So it's also important that we instill that into the younger generation too, that it's cool to be different. It's cool to be a science nerd, and it's cool to be a nerd. I always joke that I'm a science nerd, but I love science. It's everything that I love. And I was so excited to be able to bring that on stage as Miss America. And so this is pretty cool. This will cool down eventually. It's still pretty hot. But this is what elephant's toothpaste looks like. And the other thing that I'm going to mention before I'm done is that you can actually see it in the camera. This starts to get a little bit red. And I told you that the catalyst I used is potassium iodide. Has anyone ever used iodine before? Maybe you use it as an antiseptic on your skin. It's kind of like a brownish red color. And so that's part of the iodine from the catalyst that comes out. So everything kind of looks a little bit more red in the elephant's toothpaste. I tried to make it white one time because I wanted to do red, white, and blue for the 4th of July. And so I tested it without any food dye, and it turned red because of the iodine, which is really part of the scientific experimentation when you're designing these experiments and demonstrations, is you kind of have to try something and see how it works. So I'm really glad that I got to share this with you. I know that we have a few questions. We have an opportunity for anyone watching online to ask questions, and I know that we have a couple.
Our first question is from Megan in Allentown.
Awesome.
You have become a role model for many girls who want to pursue science careers.
Yes.
Who is your science role model? Who inspired you to pursue science?
Ooh, that's a hard one. I think in terms of the demonstration piece of this, as Miss America, I've been really inspired by a woman named Kate the chemist, who also is a science entertainer and goes around and does science outreach like this. But as someone who was just pursuing a career in STEM, I didn't have a particular person that I kind of like idolized. I think it was just the exploration from people around me when I was a young person. I think that anyone can be a role model for a young person to pursue a career in STEM if you expose them to the right thing. I think that places like the Vinci Science Center are a great way to do that for young people so that they can kind of get that exposure and have those experiences that will give them the knowledge of all these potential opportunities in their life and their career. So not a particular person for me, but hopefully I can be that role model for other young women.
Thank you. Next question is from Chris in East Berlin.
Cool.
What would be your advice for girls looking to follow their love of science when faced with the statement that STEM is for boys?
I would say, why is STEM for boys? Because quite honestly, STEM is not a gender-specific job. A lot of STEM jobs do tend to be male-dominated, and I don't fully understand why. I think that if we're able to demonstrate our skills as a woman, there's no reason that we can't be in science. And I think that that's what's really important about what I'm doing this year. I kind of joke that I'm the science princess because some people think that I'm a Disney princess when I come into their classroom. But in reality, you can be a feminine woman. You can love, sparkles and pink, and you can also love science. Those things are not mutually exclusive. And I do think sometimes girls think that they have to pick between being a girly girl or being a science nerd. And I think that you can absolutely do both. And so I would say, why is STEM for boys? It's not for boys, it's for everybody.
Great. From Anne in Allentown, you have said that it's your mission to show kids that science is fun, relevant, and easy to understand.
Yes.
What message do you give to science teachers as you travel around the country advocating for STEM education?
I think the biggest thing that I would like to share with science teachers is to make science relevant to every student's life. That was how I learned the best, when I was able to apply any concept into my everyday life. So I use really household things like just cooking. That's a great example of how chemistry and biology can be applied into everyday life. Make it relevant, because that relevancy will allow that concept to really be understood by that student in a different way. I think that demonstrations, quite literally, although they're fun, are also a really important tool in teaching STEM concepts so that that can be visualized. And so that would be my biggest piece of advice for science educators.
Great, thank you. We have a question from an online participant, Atul. What was the first experiment you ever did?
It depends on how we take this question. So my first demonstration I ever did was elephant's toothpaste, and that was getting ready for Miss Virginia. But I mean, my first experiment, I've been in science, being a science student for almost my whole life now. I've done thousands of experiments in the lab as a student. But I did spend a ton of time in my senior year of college working on my own senior thesis project, where I studied sense and antisense RNA in the genome and how that affected circadian rhythms. So how you actually wake up and do certain things during the day at certain times. So I studied that. That was my first real experiment that I worked on in terms of research. But I'm able to do lots of different demonstrations throughout my time. This was the first I did, but now I have a big repertoire of other ones that I get to do, which is pretty cool.
Thank you. We have a question that we think everyone wants to know. What's the best thing about being Miss America?
Oh my gosh, I think the best thing about being Miss America is literally being able to focus on bringing science and different educational programming to people full time. So I was a full-time student when I won Miss America. And now I get to take 2 years off to travel around the country and basically have fun and bring science to people and educate people about drug safety and abuse prevention, which I also do outside of doing the STEM education, and get to go travel to events, and people are excited to meet Miss America, and I get to meet them and kind of make their day. And it's a special opportunity that I'll only get to do once. And so the answer is doing the job of Miss America is the best part of being Miss America, which I haven't gotten to do a lot of because of COVID. And so being able to actually get out and see people and make that interaction and bring science to them is my favorite thing to do.
Great answer. Thank you. Another one from Megan in Allentown. You're extremely successful in your life and career, but was there ever a time you felt like a failure, and how did you deal with those feelings?
Do you have a day? To answer that question, I think the biggest time that I have been really successful, and I'm really lucky, but I actually went to college originally to be an engineer. And I got to college and I realized that I didn't like the school I was at and I didn't like engineering. So I ended up having to change my entire path. And that's also why I talk about the fact that you don't have to be excellent or love every piece of STEM to have a successful STEM career, because engineering didn't really suit my skills and talents and passions in a way that biochemistry did. And there was nothing wrong with that. And I shouldn't feel like a failure because I wanted to study biochemistry instead of the engineering I was in. There was nothing wrong with that. But it's important to know that you have to figure out what you like, because if you're going to dedicate that amount of time and effort to it, you have to be in a place that you're comfortable with and that really suits you too.
Great. From Haley online, what's your favorite part of science?
My favorite part of science is that it's all around us. That's like kind of my catchphrase now, is that science is all around us. And I said that during my demonstration on stage. But literally every single thing that we touch, I mean, even from this tablecloth to the computer to, you know, maybe a packaged food that you ate this morning, has been touched with science in some way. It's in every single thing that we touch. So it's relevant no matter what your passions are. If you're an artist, science has touched what you do in art in some way, whether or not it was creating the paint or the canvas or something that you're using, it touches everything. And so that's my favorite part of science, because it's relevant in everything we do.
Awesome. From Gideon, also online, how do you know all the experiments?
I've been in school for my whole life. I mean, so I've learned a lot about science throughout my time. But honestly, one of the really cool things, I'm still learning. And that's one of the things that people think, that I know everything, and I don't. And you're not expected to know everything all the time. I do a lot of research on cool demonstrations that I think are cool and that I think teach really important science concepts. And I will tell you, if you're watching this and you like YouTube, some of you might be watching this on YouTube. Go on and search for different science demonstrations, look at science videos, be inspired. Don't just listen to me, listen to other science educators too. There's so much content out there, and sometimes I get inspiration from other science content.
Thank you. Sort of along with that, another question from River Rock Academy. My students asked if Bill Nye the Science Guy influenced you in becoming more interested in science.
I have to tell you, when Bill Nye came out on the TV, so when I was in school, they would roll out the TV in science class and like put the tape in, and we would watch Bill Nye on like a rainy day. And that was the best thing ever. So I absolutely loved Bill Nye. I think that is kind of the concept that I hope to embody in this, is being able to make science that thing that you look forward to when you're learning about it and making it fun. So Bill Nye is super cool. And apparently he actually saw my demonstration online at some point. I heard through the grapevine, because I know a guy that knows a guy. That really filled my heart.
Wow, incredible. So another question from online from Frank. How is it being a scientist?
How is it being a scientist? It's awesome. It's particularly interesting to be a scientist in the middle of a pandemic. And so one of the interesting things is that I actually get to adapt my science to be virtual. So just like maybe you're watching virtually right now, I'm able to bring science to a lot of online communities and show why I love science to the world. But being a scientist right now is really interesting because I can't go out and do a lot of this stuff in person. But that is what the beauty of the T in STEM brings to me with the technology, is being able to share that content virtually.
Great, thank you. And this is our last question that we're
Okay.
going to ask. What is your favorite science experiment you have ever done? That's from Wyatt online.
Oh, this is a hard one. I want to say that this is my favorite demonstration that I do because it was the one that helped me win Miss America, and it was the first one I ever did, so I'm a little partial to the elephant's toothpaste. But I think my favorite science demonstration that I have done, I do this on my YouTube channel, is Candy DNA. I was talking to some of you in this room about it earlier this morning, where you can use Twizzlers and mini marshmallows to actually create your own DNA. That one is a really cool one to do. But in terms of like actual experiments that I've done, my senior thesis project was probably my favorite when I worked on the DNA and RNA. But that one even stretched my brain very, very far. But that was one of the awesome things, is being able to really stretch my capacity and learn a lot about genetics and science.
Great, thank you. Any final thoughts?
I am grateful to be able to share science with everyone here today. And I'm glad that you all are watching virtually, and I hope that you can play this back and continue to watch Elephant's Toothpaste. And you can even try this at home with safe home chemicals. So definitely go on YouTube maybe and look at, I have a YouTube video up about how to do Elephant's Toothpaste at home. It's really fun. You can do it with yeast and a water bottle. So definitely try it.
Thank you so much for being here today.
Thank you.
And for everyone watching, if you want to see more of Camille, please join us tonight on the Vinci Science Center website and PBS 39 streaming live for our Women in Science and Engineering Forum at 5:30 p.m.
Awesome.
Thank you.
Thank you, guys.